Hello and welcome. Got a quick one for you today. I'm going to be doing a problem from the Financial Modeling University Challenge that the FMWC put on last weekend. I did a video of one of the problems from the semi-finals a week or so back. The finals was on last weekend. They had 3 knockout rounds to whittle down from 8 to 1 winner. If you haven't seen it, very impressive group of people. I'm still kind of in awe that people are able to do this stuff in university, because I certainly wasn't able to at that point in my life. Now, I said I was going to be focusing on problem-solving problems for the next little while, and now I'm immediately going back on my word because I just kind of liked this one and wanted to give it a go. But it's actually, even though it was in an esports format, it is a pretty traditional financial modeling problem, and a slightly technical one in some ways, which is probably a little bit the challenge for, even though they were a very impressive group of people. I think this is probably a little bit on the technical side for some of that group. So I thought this would be a good one for me to do a quick demo of. So what's the idea? The idea is you've got an aging asset. In my head, it was a piece of art. I don't know if it actually spells that out in here, or maybe it's fine wine or something. But so you buy it on this date, middle of 2022, for $820,000. We're going to model a 42-month period, so through to the end of 2025. And the important thing is it's an appreciating asset, so it increases in value by 15% every year that you hold it. But you have to store it at a cost, and you have to insure it at a cost. And those costs inflate, and you pay them on different periods and whatever. And we're interested in figuring out the NPV of the investment. So let's dive right in, because I do actually want this to be a quick one today. First thing I'm going to do is make a separate model tab, because this is one that, some of these esports ones, it's easier to kind of build across as you go, but this is definitely one where it's good to have a model. So what have we got? We've got a 42 period model. So let's just say month number. And I'm just going to do sequence. I'm going to do 43 periods because I'm going to start from 0. So I'm going to have the investment month and then 42 subsequent months. And let's put dates on these as well, just to be month end. So the first one is here, and then we're going to go EO month from there. From there, and lock in the row by this many. Copy it down and copy the format as well. And so the model runs as expected to the end of 2025. So that's good. I'm just going to lock in freeze the frames, not lock in. Well, it is locking in. Anyway, all right. So asset value, we buy it for 820,000 in the first period. I'm going to make that, wrong one. Make that red, because I'm a stickler for exceptional ones. And then it's going to appreciate by 15% a year. So this is the first kind of slight technicality. You need it to increase by 15% a year, and we're told to treat it as every month equal somewhere in here. I don't know. Anyway, trust me, it says it in there somewhere. So we're going to say times 1 plus 15% to the power of 1 over 12. And then if I copy that down, let's just first do 12 months and just do a quick sense check. Does that over that give us 15%? Yes, it does. So we're happy that's working. Carry on down. So that's the asset value. Then we need to think about the cost of storage and the cost of insurance. So the assumptions here, basically for both of them, there's some initial cost. You pay it every certain number of periods. So here you pay every 6 months, every 5 months, every 3 months, every 4 months, and then every year, starting from the month of January, the cost increases. So the baseline cost, the 10,000, increases by 3%. Here by 5%, here by 6%, here by 0%. And same basic thing. So you've got one rhythm for the asset storage, 4 different facilities you're considering storing it in, and one rhythm for the asset insurance, and again, 4 different facilities you're considering storing it in. So the way it's laid out, most of the questions are specific to facility 1, and then we have a few questions at the end about selecting the best facility. So what I'm going to do is I'm just going to say active, and I'll put in, I don't know, I'll just drop it, I guess, jump these down and put it up over here. And it looks like my assumption format is this. And I'll just make this a list, picking from these different facilities. Alt-DL to get data validation, and then you pick list, and then you point to the range, and then you get the little drop down here where you can pick. So let's say active facility. Spelling, as you know, is excellent. Okay, so we're going to XLOOKUP this in here. We'll lock that as well, returning from here. and then, sorry, I want to. So if I hadn't already put the formula in, I would just paste the values in number formats over here and then delete it and then put the formula in. But since I have, I'm going to paste values in number formats over here in a cell that's otherwise unformatted, and then copy and paste formats over there. It's a little bit convoluted, but it works. And then I'll come down here, and I should be able to paste in the exact same formula because I locked in what I'm looking up and where I'm looking it up, and now I'm just returning from this array here. So now we're only paying these costs every 6 months, 5 months, 3 months, 4 months. So first thing I'm going to do is work out an index to say how much in total has the price gone up. So I'm going to do, what have we got? Storage and insurance. So I'm going to do a storage index and an insurance index. And obviously they're both going to start off with a value of 1. And I'll just format them as numbers with 2 decimal places. And again, because this one is different, it's obviously not at all relevant if you're in the competition, and don't waste your time doing it. I wish I could turn it off sometimes, but I can't. But in real life, it's very important to format things that are different so that you don't, copy down and destroy your model. So anyway, then I'm going to say if the current month, oops, not mod, month, lock that in so I can copy that piece across. If that month is equal to 1, then this times 1 plus this, and lock that in. Otherwise, just take E4, which is the previous value, carry that down, and so we should see in January it goes up by 5% the active one. Yes. Oh, sorry, let's go back to facility 1 because that's the one that the initial questions are about. So 3% in January. Then the next January it goes up another 3%. The next January it goes up another 3%, and then we're out of time because that's the end of the model. Okay, and then same basic thing here, except I want to point to a different cell. Which is this one. And let me just double check that everything else stays the same. So month of the date stays the same. Previous value is a relative, so that's moved across. That's the same, that's the same. Okay, so we're good there. We've got our indices. So then let's do storage cost and insurance cost. And now this is going to be, so nothing in month 0, so I'll just leave that blank. Or let me just put a 0, and again, just make that red. And now these ones, let me copy this format first. Sorry, I want to do that all the way down. And then I want, because these are going to be zeros in a lot of months, I prefer to format my zeros this way. So I'm just saying this is the format that I had before, which is, commas and no decimal places is for positive numbers, that with a minus in front of it is for negatives, and just a dash is for 0. So I'll say OK to that. And then here I'm going to say if, so how are we going to do this? The easiest way to say, I want a cost to hit in month 6, 12, 18, 24, 30. Here I want it to hit in 5, 10, 15, 20. Well, if you know your modulo arithmetic or clock arithmetic, then the easiest way to do that is to say if it's 0, mod the number of months. So in other words, mod 6, we go 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 0. And so those zeros are exactly where we want to make the payment. And so we're going to say if mod month, and the thing we want to take at mod is the number of months in the active scenario. If that is equal to 0, then this amount of money times the index, which is E5, otherwise 0. And then we'll copy that down, and we should, sure enough, we make a payment after 6 months, 12 months, 18 months, and we find here, so in the first year the cost is 10,000, and then both of the payments in the second year are 3% higher, both of the payments in the third year 3% higher, both of the payments in the last year 3% higher. So that's all good. And then we'll just copy across and see what references we need to change. So that stays the same. That stays the same because it's a relative reference. It just shifts over from storage to insurance. It's the good thing of kind of having your model laid out parallel. So it's just these two things that refer back to the assumptions I need to update. So let's do that. I want mod 7, and my base cost is 12,000. That doesn't look right. One is not mod 7. What's going on here? Mod month 7. That's okay. So Alt TUF gives you formula auditing. So month of that is 7. Oh, sorry. Beg your pardon. Beg your pardon. Beg your pardon. I did not mean to do mod of month. So okay. So I actually got lucky and unlucky that my formula accidentally worked out right here. I did not mean to do mod of month because that will not work, as you can see here, for 7. Then it's only hitting in month 7, but we're supposed to be counting number of months from when we bought in. So I don't want the month of the year, I want the month in the model. So instead of taking the month number in the year, which is 6 for June, 7 for July, 8 for August, etc., what I want is this month number. So yeah, that was, like I said, both lucky and unlucky that I happened to have 6 active. Because the only reason it worked for 6 is because 6 evenly divides the number of months in a year. And so, 6 here is 0 mod 6 exactly when 12, which is the number of December, is 0 mod 6, but that did not work for 7. So we fix that, and then we fix it over here as well. And now we should work a little better. Whoops. Okay, so this time we have a payment happening in the 7th month, good, and then we have another payment happening in the 14th month, good, and then we just copy that the rest of the way down. All good. Okay, so then we want to look at discount rates, and we're told basically because the risky, you're taking more risk earlier on, you have a higher discounting rate in the earlier stages. So we use a discount rate of 8% for the first 12 months, then 7%, then 6%, then 5%. So first let's just do discount rate, and then we'll do a present value factor. So for our discount rate, we just want to look this up. So I see 2 options for how to do this. One is we can kind of take advantage of the fact that this is kind of more neatly structured than it looks like. So we could say, the first 12 go here, the next 12 go here, the next 12 go here, and the next 12 go here. So I could take my my month number divided by 12 and round up to a whole number, and that would tell me all of the first 12 months get the first row, all of the next 12 months get the second row, etc. I don't love that because I would like, given that I have assumptions here, I would like to be able to change the assumptions and have that change in the model. So instead, I'm going to change this a little to work more like a lookup table. So I'm going to say month from. Sorry, oops, let's align that left. And then I'm just going to make this 1, 13, 25, 37. And if you like, you can come here and format those as month 0. So you can say from month 1, it's this rate, from month 13, it's this rate, 25, this rate, 37, this rate. And then you can do a better lookup here. And again, I'm going to just copy over a hard-coded 0 in red there. And then I'm going to say xlookup, this value in this array. Whoops, what did I do there? Lock. And then how do I want to look it up? So, sorry, my return array is going to be that. Again, I'll lock that in. If not found is fine. Match mode, I don't want exact, I want exact match or next smaller item. So in other words, a 2 would match to 1, 12 would match to 1, etc. And I guess once I've done that, it doesn't matter whether I search first to last or not, but I'm going to search first to last anyway, because that's how it should go. And so that's giving me 8% to start, which is good. It should give me 8% all through the rest of that year, then jump to 7%, and it does. And keep 7% all through that year, and it does, then jump to 6, and it does, and do that through month 36, and then jump to 5, and it does. So that's all good. So now my present value factor, again, just like these insurance indices, it's going to start off at 1. So my PV factor is basically going to say, if I have a dollar of either cost or return in a given month, what is that worth in month 0 at the time I make the investment? Because that's where I want to discount everything back to. And this is the sort of first principles equivalent of just using the NPV formula. And you need to go first principles here because you have a variable discount rate, so you can't use the NPV formula. So my PV factor is going to be this divided by 1 plus this to the power of 1 over 12. I'll format that like that. And then if I come down here, hopefully I will find that this over this is exactly 1.08, and it is, so that's good. I come down here, and again, just do a quick check. That should be exactly 1.07, and it is. And one more time, just do a quick check. This, sorry, I put it in the wrong one, but that's good. That shows you if you put it in the wrong place, it does go wrong, and that's important. Okay, so that's my PV factor. Now let's start answering some questions. What is the value of the asset at the end of month 12? Here, 943. What's the value of the asset at the end of month 1? What's that? What's the value at the end of month 42? In month 18, the value first becomes greater than $1 million. What's the exact value at the end of month 18? So it's just giving a little hint there that it should, and it does indeed go past $1 million for the first time in month 18, so that's good. How much will you pay for storage in month 12? Storage cost, month 12. Fine. How much will you pay for storage in month 42? Is that? How much will you pay for insurance in month 14? No, sorry, back up here. Second payment is that one. How much will you pay for insurance and storage during the first 10 months? 10, yes, good. How much will you pay in total for insurance and storage in 2025, which is the last year, so we'll come down here, all the way back up to January, 12 by 2, yes, that's right. And what are the total insurance, sorry, yeah, total over the whole time frame, so that's just summing up everything. Okay. So this level is just to make sure your discount rates are working. So what's the value of $1 million in month 12? So that's our discount factor here is just the value of $1. So we're just going to say 2, 3, 4, 5, 6 times. So we go to month 12 first, and it's that. What's the value in month 24? And it's this. What's, oops, sorry. We gotta keep doing the times a million. So try that again. Month 24, it's that. What's the value in month 1? I could make this a lookup, but then I'd have to put the ones in somewhere, and that's fine. And at month 42 is this. And then present value of all costs over the 42-month horizon. So let's do PV of costs. Sum times PV factor. Again, I'll copy this format and we'll put that in. Okay, and then we're interested in the NPV. So now you might, my first thought when I looked at this was to think, oh, maybe you need to do a data table view here. And then I realized actually you don't need to do a data table, because if you think about the present value, if you sell in one particular month, it's just the present value of the asset, and we have the value of the asset in that period and the PV factor, and then the sum of the PVs of all the costs that have gone before, and we have the PVs all here in one column. So NPV for sale in month can just be current value of the asset times the PV factor minus the sum of all the costs up to that month, lock in the 4, and just it's a little counterintuitive, but it does spell out somewhere in the assumptions that you know, there's no accruals for storage and insurance. So like if you sell here, you don't end up paying any storage costs. Not very realistic, but you know, that's how it works in model land. So now we can go straight on and answer NPV questions. The NPV of the investment sold at the end of month 6. Let me just come over here. At the end of month 12, it's this one. The end of month 42, it's this one. Maximum NPV is just the max. And what month does that occur? So we're just going to match that against the array of them. And it's, oh, sorry. And then very important, got to say -1, because you got, I'm including month 0 actually. Might be more elegant to just match it against the months after the first one. And if you think about it intuitively, this kind of makes sense, right? The asset is appreciating so much that it's much more than you know, these storage and insurance costs. So the only thing that stops it from being in the last month is the fact that both storage and insurance costs hit in the last month. So if you get out 1 month before that, you get almost all the asset appreciation and you don't have to pay your last several months of storage or insurance costs. So that's why. That's kind of the logic for 41. Determine the facility that has the lowest total cost over the 42 months. So now we just need to do a data table for the facilities. I'm going to grab my facility assumption and bring it over to my model page. And then let's take all of these. So total costs, it's just this. Tot cost. What else did we want to know? Highest NPV 12. Highest NPV in month 24. And then highest max NPV. So NPV in month 12 is this guy. NPV in month 24 is this guy. And the max NPV is this. And then we just do a data table. So again, I've shown you this before, but data table is just saying take each of these values, put them into that cell, and tell me what each of these things become. So just copy that format across. And then best. So the best is the lowest. I think we want the lowest storage costs and the highest everything else. So min of those and max of all of these. And I'm going to take those and plop them in here. Sorry, equals And that's how you do it. I told you I was going to do a quick one today, and hopefully I'm true to my word. I'll see you next time. Bye-bye.